And now on to the great section 4.3. We are looking at global mins and maxes. And so what does the definition of this thing mean? All right, so the point P is going to be a global min of my function if f of p is smaller than everything else, right? That kind of sounds about right. Global mins, it should be as small as you get. Kind of notice a key thing here, smaller than or equal to. We'll see kind of a special case with that in a second. Global max also makes sense. Basically what it says here is your output value is bigger than everything else. And there's this weird funny word at the end here, on your domain. What does that domain thing mean? Well, it's actually, we're only going to consider some x values for these problems. Now, what do I mean? Let's take a look at a graph. So, in this graph, we want to find the local mins and maxes and the global mins and maxes of this f of x right here. And we have a bunch of points written down, and we want to kind of identify which ones are which. And so, notice we're only considering x values from a to g. So, a to g is my domain here. And in formulas, they'll kind of have to explicitly spell this out, but in a graph, they might just graph only part of the function. So if I want to find my local maxes, I need to find points where everything around that point is smaller than the point itself. So here's one that probably looks a little bit obvious, right? This D. Everything else is kind of smaller than it. So I'll start with that. That's a local max. But there's actually two other points on this graph where if you look at all the other points close to them, you're going to get smaller values. And so what are those 2 points? I'll give you a hint. They're very special points. They're these endpoints right here. And so if you look at all the points around A, all the points around A are less than f of A. If you look at all the points around G, all the points around G are less than f of G. So these are actually also local mins and maxes. These are all just local maxes. The local mins are going to be at the points that are kind of less than everything around them. So B is a point where everything around B is bigger than B. F is a point where everything around F is bigger than F. So B and F are my local mins. Now, is there anything else? C or E? Not really, and then those are the only other options I have. But what about the global maxes and the global mins? That's the whole point of why I started this section. So the global max, we're just saying, what's the biggest? What's the biggest here? What's bigger than everything? And for the global max, it actually has a relatively simple answer. It's just A, right? A is the biggest point on this whole thing. It's bigger than all the things close to it. It's bigger than D. It's bigger than G. It's the biggest. What about my local mins, though? B is smaller than everything around it, but is it smaller than F? No. It's actually equal to F. That's what it's supposed to look like on this semi-poorly drawn graph. But what happens for my global mins when I have two values that are as small as everything? And so what I actually want here is that my global mins, I have two. Sounds weird, but I have two. B and F are my global mins. So big idea, globally, you're only going to consider values in a certain range. And on a graph, all you need to do is look for what's the biggest or what's the smallest. And if there's a tie, you get both.